Hello everyone, welcome to our YouTube channel, and I hope that you all are doing well and enjoying this series of basics of mathematics, right? And we already have covered two sessions, and in today's session we are going to bring you the basics of fractions, right? And for the fractions, I'm telling you that you get minimum 2 to 3 questions directly in your competitive exams. Whether you go for the bank exam or SSC exam, you get minimum 2 to 3 questions, right? And in today's session, we are going to cover all those concepts, all the basic concepts of fractions. Along with that, we'll also be covering all the advanced level questions, right, that are being asked generally in the computer exams, right? So stay with us, stay tuned, and keep your copy and pen with you so that you can follow the things along with the session, right? So let's go to the class, right? So first of all, we need to understand what is the fraction. What do we understand by a fraction, by the meaning of fraction, right? So fraction is what? In layman language, I just want to tell you, right? Normally what we do, I just take one example, right? We take our meal daily, right? And say in the breakfast I take four chapati or four breads, right? So normally I have a habit of taking somewhere around four rotis or four chapati every day, four breads every day, right? Now today I'm feeling more hungry, so I need a little bit of extra, but I can't eat one full bread, right? So what I need four and a half. I need half bread, right? So when the numbers are not complete, we need some fraction, some part of a number. There the role of fraction is applied, right? Say normally I'm eating four breads, but I need a little bit more. So say I take half bread more. So I will say that I have eaten four and a half breads. Four and a half breads are taken by me, right? So this half is fraction, right? Sometimes that we use the number, like we have to say that how many students are there. How many students are there means there will be 10 students, 20 students, 30 students in a class, right? So that cannot be 10 and a half. 20.5, right? That cannot be there, right? But there are certain things where we need the fractions, we need the value in the fractions, right? So fraction is basically a part of a number, right? Like we write a number in the form of p upon q, right? This is called a fraction, right? Where p is less than q. P is less than q, and normally we call it to be a proper fraction. We call it to be a proper fraction, right? Proper fraction mean to say the fraction is proper, means this number is less than 1, right? And if we have, suppose in case that I write is 7 upon 9, so this is a proper fraction, right? But in certain cases we also come across numbers where we write the numbers to be as 11 by 7, right? So here 11 is more than 7, and this number 11 by 7 as a whole is greater than 1, so we call it to be improper fractions. Improper fraction, right? And when we solve the question, right, generally question is asked in the form of proper fractions, and in case it is not in the form of proper fraction, then normally we convert into the proper fraction to solve the question, right? And sometimes we have to convert the proper fraction into the improper fraction to solve the questions, right? And there is also one mixed fraction. There is also one mixed fraction, right? I just want to know mixed fraction, right? You might be knowing it, right? Mixed fraction is what? This is a improper fraction, right? And how do we write it in the form of proper fraction? We divide 11 by 7, so 7 into 1, 7. So remainder is 4, so it is 4 by 7, 1 4 by 7. This is the mixed fraction, right? How do we do it? Let's say 11 is there, and we divide this 11 by 7. 7 into 1, 7 is there, minus 7, that's 4. So this 4 is remainder, this 1 is quotient, and this 7 is divised. So we write 1 4 by 7, right? This is the mixed fraction that we get. Clear? So these are the fractions, and in fraction is normally the proper fraction is less than 1, right? In case the fraction is more than 1, then we call it to be improper fraction, right? Done? Okay, so in today's class we also going to learn that how to add a fraction, how to subtract a fraction, right? And how to multiply and how to divide the fractions, right? So next we go to this, what is the meaning of a fraction, right? If it is given that there is one fraction that 3 by 7 is given, right? There is one fraction 3 by 7 is given. What does it means? It means we are doing 7 parts of a thing. 7 parts of a complete thing, and then out of 7 we are taking considering only 3 parts. Sometimes we say that give me half bread or half roti, right, or half apple. What does it mean by half? We normally ask them make 2 parts of this thing, right? This is the whole thing. Divide it into 2 parts. It give me 1 part. So this part is called half, 1 by 2. What we have done? We have done the 2 parts of the complete thing, and then we have taken only 1 out of it, right? Say if it is given this 1 by 3. 1 by 3 means you make 3 parts of a certain thing and then take out 1 part, only 1 part out of that, right? It's a 1/3, right? If it is written that's 2 by 5. 2 by 5 mean to say do make 5 parts of a certain thing, and then out of those 5 parts you have to take only 2 parts, right? If 7 by 13 is there, then out of 13 you have to consider only 7 parts, right? So that has to be followed in this way, right? This is the meaning of a fraction. Clear, right? So when we go to the calculation of the fraction, we need to take care of the certain things, that how the fractions are going to be operated, right? So first of all, we start with the simple addition part, right? How do we add fractions, right? It's pretty simple, right? See, normally if we come across, if it is given that if 2 by 3 is one fraction plus 3 by 4 is another fraction, right? If we have to add this fraction, so what we do? How do we follow this? We simply take LCM of 3 and 4, right? Because we have to make denominator to be same. We take the LCM of 3 and 4, and this LCM is going to be 12. LCM of 3 and 4 is 12. So now 12 is divided by 3, we get 4. 4 into 2 is 8. We get 8 here. Then this again 12 is divided by 4. So 4 into 3 is 12. So 3 into 3. This 3 is multiplied by this 3, and 3 into 3 is 9. So what we get? We get here 17 upon 12. And 17 upon 12, this is the improper fraction, right? And we simplify it. 12 ones are 12. And then 5 is remaining. So 5 upon 12. This is the sum of 2 by 3 plus 3 by 4. Right? This is how we calculate it. Done? Now, if we go ahead, if we move ahead, right? If it is given that this number is 6 plus, I will take 5-6 examples, 5-6 simple examples. Then we will also practice certain questions, right? If it is given that there is number is 6 plus 5 by 8, right? So what does it means? 6 is a complete number and 5 by 8 is a fraction. So we can simply write it to be 6 5 by 8. We write it to be 6 5 by 8, right? 6 5 by 8 means 6 is complete and 5 by 8 is a fraction. It's a mixed fraction because there will be 2 parts. One will be the complete number, other part will be the fraction part, right? So mixed fraction means to say there is one complete number as well as the fractional part as well, right? So it is 6 5 by 8. Clear? Got it? Now, normally in our exams, when we go for the exams, we get a simple question like it is given that I just take one example, 3 1 by 2 minus 7 3 by 4 plus 10 2 by 3. Say we have to solve this question, right? How do we solve this question? How do we approach this question? What we do, normally it is being told that what you do, 3 2s are 6 plus 1. You make it, right? 7 by 2 minus 7 4s are 28 plus 3. That is 31 by 4 plus 10 3s are 30 plus 2. That is 32 by 3. Now, we take out the LCM of 2, 4 and 3 and LCM comes out to be 12. This 2 into 6 is 12. So 6 into 7 comes out to be 42. Minus 4 into 3 is 12. 3 into 31 is 93. Plus 3 divides 12. That's 4. 32 and 4 comes out to be 128. Now we solve this one. This is 42 plus 128 minus 93 if we do. So it is 7 till 100. It is 7, right? And 7 plus 28 is 35. Right? So 128 minus 93 will be 35 upon 12. Now we add up these numbers and I get it to be 77 divided by 12, and 12 into 6, 72, remainder is 5, so it is 5.12. So my answer is 6 5.12, right? This is the answer I give. Clear? I hope the question is clear to you people. This is how we used to solve when we used to solve these questions when we were in 8th and 9th classes, right? This was this chapter, this fraction is we studied 8th class, I guess, right? Now, instead of this, right, if I have a question, right, here we have made the calculation. If I have a question, say 47 2 by 3 minus 58 3 by 4 plus 69 1 by 2. Now in this question what will happen? If I change this, if I change this question, if I 47 into 3 plus 2, 58 into 4 plus 3, 69 into 2 plus 1, and then I take the LCM and then again equalize. If I follow the same process, this question is going to be very lengthy, and normally this is the kind of question that we get in our exam, right? So what we need to do, we need to go back, we need to go to the basics, right, and come back to the basic approach and solve the question in a very simple manner, right? Let's look here. What is 3 by 2? 3 1 by 2. 3 1 by 2 means 3 is a complete number and 1 by 2 is a fraction. So what we do over here, we write is 3, this is a complete number. This minus 7 is there, I write is minus 7. Then this plus 10 is there, I write is plus 10. Plus, I write the fractional part separate, right? I write it 1 by 2 minus 3 by 4 plus 2 by 3. Now, 10 and 3, 13, 13 minus 7 is 6, plus I take out the LCM of this, LCM is 12, and this comes to 6 minus, then comes out to be 4, 3 3s are 9, plus 3, 4 2s are 8, right? Then it is 6 plus 8, 6, 14, 14 minus 9, that is 5.12, and I write it straight away 6 5.12, right? I get the answer. This 6 5 and 12 is very simple, very easy, straightforward answer, right? Very easy to solve this question, right? But otherwise, if I have to solve this example I have given you, if I have to solve this example in this fashion, then it will take a lot of time. And otherwise, what we do over here, in the next step, I will write this. What I will say in this question, I have to solve this question. So what I will write here, it is 47 minus 58 plus 69 plus 2 by 3 minus 3 by 4 plus 1 by 2, right? And next, in the next step, 47 plus 11, 69 minus 58 is 11, plus I take out the LCM. LCM is going to be again this 12, 3 into 4, 4 2s are 8, minus 4 into 3, 3 3s are 9, plus 2 is this 6, right? So 47 plus 11 is, I write as 58, right? Somehow it comes out to be 58 again, plus 8 6 14 minus 9, that is 5.12, and I can straightway write the answer to be 58 5.12. The question is very easy. Straightway I can find the answer, straightway I can get the answer, right? So this is the basic thing, right? It's not shortcut, it's a basic thing that you should follow while you're solving the questions of fractions. When there's addition or subtraction there, we can straightway go ahead and follow this question, right? Let's take one more example, right? Let's go ahead and let's take one more example. Say if I get a question 97 5 by 6 minus 93 2 by 3 plus 82 3 by 4 minus say 76 1 by 2. This is the question and we want to find the answer for this. So if I have to solve this by using the fraction, then it is very lengthy, right? It will be very long process, right? But here what we do in this question, we take out the two parts. One is complete number 97, other one is fractions. We solve both the things separately. 97 minus 93 is 4, plus 82 minus 76 is 6, plus I have 5 by 6 minus 2 by 3 plus 3 by 4 minus 1 by 2. So it is 10 plus. We take out the LCM. LCM comes out to be again 12. 6 2s are 12. 5 2s are 10 minus 3 into 4. 4 2s are 8 plus 4 into 3. 3 3s are 9 minus 6, right? And I get it to be 10 plus 10 and 9, 17. 10 minus 8 is 2 basically, and 9 minus 6 is 3. 3 into 5. So it is again I get to be 5.12. So I can write the answer to be 10 5.12, right? This is my answer. This is my answer to this question, right? Very simple part, very simple question, and straight away we get the answer. We don't need to take a lot of calculations. Simple, we have to solve as it is, right? And but only thing we need to take care is whenever mixed fraction is given, take out the complete number separately and take the fraction separately. Keep the fraction separately and solve this fraction separately, right? We don't need to involve this 97 in the whole of the calculation. We don't involve 93 in the whole of the calculation. We straight away write the answers. Clear? I hope that the concept is clear to you people, right? You can directly solve the questions, right? I give you one more question. The question is 47 2 by 3 minus 36 11 by 12 plus 27 5 by 6 minus 18 2 by 3. This is the question. 18 2 by 3 or we take 18 1 by 3. This is the question, right? 18 1 by 3, right? This is what you need to solve, right? This is 1, not 2. This is 1, right? Now, but how do we approach? 47 minus 36 is straight way we can write it to be 11 plus 27 minus 28 is, that is 9, plus it is left is 2 by 3 minus 11 by 12 plus 5 by 6 minus 1 by 3, right? So 11 and 9 is 20 plus, we take out the LCM to be 12, 3 into 4, 4 2s are 8 minus 12 into 1, 12, so it is 11 plus 6 2s are 12, 5 2s are 10 minus 3 into 4, so write it to 4, right? So 20 plus what? 10 and 8, 18, 18 minus 11 is 7, 7 minus 4 is 3. So it is 3 by 12 and it cancels 4, and I can write the answer to be 21 by 4. My answer comes out to 21 by 4. The question is very easy to solve. The only thing is we need to follow it in a systematic manner, right? Clear? So addition part, I think that is the hardly any challenge, right? This is hardly an issue with it, right? We can directly use it. Like for example, this I am telling you simple, very simple example. Say it is given the 8 plus 3 by 7 is given, right? So say I have 8 breads with me, and I also get 3 by 7 bread from somebody else, right? So how much bread I have? I have 8 3 by 7, means 8 complete and 3 by 7 fractions. I have 8 3 by 7 fractions. So we can straightway attach these numbers, right? Simply when we have to add the numbers, we simply join those numbers and we get the answer, right? If we have 12 plus 7 by 11, right? So my answer is 12 7 by 11, right? Simple, right? Straightway I write the answer over here, right? Now similarly, if I have a question like if I write 14 plus 4 5 by 7, right? What does it means? Yes, you can write the answer. What does it mean, right? It's a 14 plus 4 5 by 7. 14 is complete number, 4 is complete number. So net will be 14 plus 4, that is 18 5 by 7. 18 5 by 7 is the number. 18 5, I can write the result straight way, right? We don't need to do anything. So 14 breads, it's a 4 5 by 7 breads, means 4 breads are complete and 5 by 7 breads is fraction, some part of the one bread, right? So 14 plus 4, in total I get 18 breads and 5 by 7 fraction is there, that is there, right? If I have say 17 plus 11 and a half breads, what do I do? 17 plus 11 is 28, 1 by 2. That's the answer. This is how I write it, and this is a basic thing, and we have to apply when we solve the question. We have to apply it straight away, right? Very simple, very straightforward, very basic thing, and that's going to be very helpful when you actually solve the questions. Fine, right? So this is about your addition of the fractions, right? Next, just in the continuation of addition, we go to the subtraction of the fractions. Right? How do we subtract? Right, so in subtraction that we have already seen, we have just seen that we have already subtracted a few of the fractions, right? But let's come back, let's go to the basic things, right? Say I have a fraction of say 3 by 7. I told you what is the meaning of 3 by 7. 3 by 7 means out of 7 parts, 3 parts are taken, right? Now if I have to subtract this minus 3 by 7 from 1, so what does it mean? I have a one complete part. Out of that one, 3 by 7 has to be subtracted. So what I do, I write here 4 by 7, right? Out of 7, 3 parts are removed. Out of 7, 7 parts are done. Out of 7 parts, 3 parts are removed. How much we are left with? We are left with 4 parts, 4 by 7, right? If I have 1 minus 1 by 3, what does it mean? Out of 3, 1 part is removed. How many parts are there? We are left with 2 by 3. 1 minus 5 by 8. 1 minus 5 by 8. What we get? We get it to be 3 by 8. Good, right? If I have 1 minus 7 by 10, what do I write? I write 3 by 10, right? If I have 1 minus 9 by 13, I straight away write it to be 4 by 13. Very simple. Out of 13, 9 parts are gone. 9 parts are subtracted. 9 parts are gone. But how much is left? We are left with 4 by 30, right? Next, apart from this, if we talk about the next, right? If we have a number bigger than 1, right? If we have 12 minus, say, 7 by 11, right? How do we solve it? How we are going to solve this question? 12 minus 7 by 11. So in this case, what we have to do? Normally we, how we are taught is, we are taught that is 12 upon 1, right? And take out this LCM, that is 11. 11 into 12 is 132 minus 7 upon 11. I can write it as 125 upon 11. And 11 into 11, that is 121, 11. And rest is left with 4 by 11. 121, 4 is remainder, 11, 4 by 11. This is the answer we get, right? So if the question is this one, we can solve this question very easily. But instead of this, if I get a question, if I get a question like say 47 minus 31 upon 38 is what? Right? So what's going to happen? Now I have to multiply 47 with 38, and it will take a lot of time because I don't have a calculator in the exam, right? So 47 into 38, first I multiply, then I subtract minus 31, and then we get improper fraction, and then finally I divide the number by 38. Again I have to divide the number by 38, right? So here, in order to solve such questions, we apply a very simple approach. See what we have over here 12 minus 7 by 11. This is a question we want to solve, right? Now what is this? How much this is? Since 7 by 11 is a fraction, is a proper fraction. So it is a proper fraction, so it is less than 1. Since it is a proper fraction, so it is less than 1, right? So I don't need to involve the whole of the 12 to subtract this. What I can do, out of this 12, I can write 11, keep 11 apart. I can just take out 1 out of 12. This 1 will go and subtract this 7 by 12, 7 by 11, right? I write it 11 plus 1 minus 7 by 11, right? I can write 12 in this form, 11 plus 1 minus 7 by 11. So what does I get, right? 11 plus 1 minus 7 by 11 will give us, that we have done just in this part, right? We have already covered this one, right? What we get? We get it to be 11 plus 4 by 11. And 11 plus 4 by 11 is very simple. It is 11, 4 by 11. Straight away we get this answer. And this is the answer we got over here as well. Fine. Now, if we have to solve this question, 47 minus 31 upon 38. So what I do, so I know this 31 upon 38 is less than 1. So what I do, from 47, I write 46 plus 1 minus 31 upon 38, right? So 1 minus 31 upon 38 will be 46 plus this will be 7 upon 38, and I get the answer to be 46 7 upon 38. Right? Very simple answer, right? 46 7 upon 38. Very simple answer, very easy to follow, right? Hardly an issue with it, right? Clearly, without sweating, without dropping a sweat, right? Without doing anything, without making much of the effort, we can straight away get to the answer. Easy? Done. I hope that you are able to solve this question. I hope that you are able to grab this concept, right? Because this concept is very easy as well as the important one for you people to learn, because this is what we do. This is how we apply in the actual questions, right? Let's take a few more examples on this, right? Say if I have a question, say 28 minus, say 11 by 17. So what I do? It is less than 1. 11 by 17 is less than 1. 28, out of 28 I take out 1 and rest I will be left with 27. So I write 27 over here, and 1 minus 11 by 17 is 6 by 17. Very simple, one step question, right? In one step I can find the answer. Say it is given as 39 minus 12.17. So I know this is 1, this 12.17 less than 1. So I take out 1 out of it, remaining is 38. So I write as 38, 1 minus 12.17 is 5.17, right? If I get 43 minus 6 upon say 19. So nothing much I need to do. Simply 42, I take out 1 out of here, rest is 42. 42 and remaining is 13 upon 19. 42, 13 upon 19, this is the answer we get, right? So it becomes very simple if we actually go to the basics of the concept, and the question will become very easy, right? The only thing we need to do is just understand the concept and apply it wherever it is applicable, right? Done, right? And next, after this we go to the next stage, right? If we go to some another level, some a bit difficult one, right? Say if the question is given is 26 minus 11 7 by 9. So this is the question. 26 minus 11 7 by 9. How do we solve this question? Now we need to understand what this fraction is. This is 11 complete and 7 by 9 is in fractions. So what I can do, this number is 11 7 upon 9. This number is more than 11. It is more than 11, but this number is less than 12. Because this is 11 plus a fraction, a proper fraction. 7 by 9 is less than 1. So it is 11. 11 plus something, right? 11 plus something, but still less than 12. So what I do, out of 26, I take out 12 and remaining is 14, right? I take out 12. What this 12 will do? This 12 is going to subtract this one. From this 12, I'm going to subtract this number, right? And how much I will be left with? I will be left with 14 plus 12 minus 11 is 1. 12 minus 11 is 1. I have taken a number, one number more than 11. So that after subtracting this, I'm left with 1. And from that 1, I can subtract 7 by 9. And 7 by 9, 1 minus 7 by 9 gives us 2 by 9. And my answer is 14 2 by 9. Right? Should I take more examples of like that? Right? Say 38 minus, it is given to be say 16, 11 by 17. Now, so friends, if you have to solve this question, right, through the traditional method, it will take a lot of time. But here, you know, it has become very easy, right? What I do, it is 16, 11 by 17. So it is 16 plus 1, 17. This number is less than 17. So I take out 17 out of this, and what I'm left with? I'm left with 19, right? So I write 19 over here. 17 minus 16 gives us 1, and 1 minus 11 by 17 gives us 6 by 17. Straightway you can write the answer, right? So it is given that 47 minus 31, 17 upon 23. This question seems to be a very complex one, but I can write the answer in a single step. It is 31, 17 upon 23. So this number is less than 32. It is more than 31 but less than 32. So I take out 32 out of this number, and what I'm left with? I'm left with 15. So I write 15 over here. 32 minus 31 is 1, and 1 minus 17 upon 23 is 6 upon 23. Very simple, very easy concept, right? But if you know it, it will help you in solving a question in say 2 to 3 seconds. But otherwise, if you don't know, then you will be stuck in a lot of calculation, right? So this is what I want to tell you, that you just try to follow the simple things, simple approaches, and the things are going to become very easy. Clear, right? And out of this, normally we get one question based upon the fractions, right? On what we have done till now, right? We normally get the addition and subtraction sum on the basis of BODMAS, and we have to apply the approaches that we have learned till now. Clear? Like if I give you one question, if I have a question, say it is given that 17 7 by 12 minus 9 5 by 6 plus 14 5 by 8 minus 11 3 by 4, right? If I have to solve this question, so what I do, what is the approach that I need to follow? 17 minus 9 is 9 is 8, and 14 minus 11 is 3. So 8 and 3, it is 11, plus 7 by 12 minus 5 by 6 plus 5 by 8 minus 3 by 4. So what I write is 11 plus, I take out the LCM over there, that's 24. 12 into 2, 7 2s are 14, minus 6 into 4, 5 4s are 20, 8 into 3, 5 3s are 15, minus 4 into 6, 6 3s are 18. So how much I get? 11, and this 14 and 15 gives us 29, and minus 20 minus 18 gives me minus 38. So minus 38 and 29, I get it to be minus 9 upon 24. So minus 9 upon 24 gives me 11 minus 3 upon 8. So how much I get? If I have to subtract 11 minus 3 upon 8, I divided it by 3 each, so it is 3 by 8. So 11 minus 3 by 8 comes out to be 10. I have taken out 1 from here, and 1 minus 3 by 8 is 5 by 8, and here I am left with 10. So my answer will be 10 5 by 8. So questions will become very easy if we apply these approaches, right? So what you need to do, you take out the previous year's questions, or take out the question based upon the fractions from the books, right? Even in IBS books, you will get these questions, and you can solve these questions applying these concepts. If you apply these concepts, right, you will find the question very easy. Done? Okay, fine. So let's move here. Let's move on with the next type of questions. Next is very simple, right? Somewhat little bit different, right? But very simple concept. Sometime you might have come across that we get question like 1 plus 1 upon 1 plus 1 upon 1 plus 1 upon 1 plus 1 by 2, right? So how do we solve this question? Right, this question you might have found many times as simply x is equal to this. So we have to find it what is the value of this, right? So normally how do we solve this question? The traditional method is simply you solve this part, right? First you solve this part. This will give you 3 by 2, right? 2 1 is 2 plus 1, 3 by 2. Then this 3 by 2 has to be reversed, because 1 upon 3 by 2, so it has to be reversed. It will become 2 by 3. Then 3 1s are 3, 3 plus 2 is 5 upon 3. Then again this whole has become 5 by 3. Now this needs to be reversed. This will be 3 upon 5. 5 1s are 5 plus 3, that becomes 8 upon 5. Again it needs to be reversed. This will be 5 upon 8, and 8 1s are 8 plus 5, that is 13 upon 8. We get the answer to be 13 upon 8. This is the answer. Clear, right? So we need to understand how do we solve these questions. This is one way of solving this question, right? But otherwise, in examination, We can find the question easily. We can solve the question very easily just following one simple approach. 1 plus 1 upon 1 plus 1 upon 1 plus 1 upon 1 plus 1 upon 2. This was the question. So what we do, we solve this part. This 1 plus 1 by 2 is 3 by 2, right? This is for the standard. This is the standard question that is being asked in the examination. So we need to follow a standard approach for this, right? So it is 3 by 2. Then what do we do? This is 1 plus 1 upon something, right? So next, in the next step, what we do? 3 and 2. We add 3 and 2. Numerator denominator, that is 3 and 2 is 5. And we take this 3 to the denominator. This 3. 5 and 3. In the next step, 5 and 3 is 8. We write here. And this 5 goes to the denominator. This 5. 8 and 5, that is 13. And this 8 goes to the denominator. This is 13 upon 8. So my answer becomes 13 upon 8. This is what I have got after calculating, after making so much of calculations. Straight away we get the answer, right? And how many times we do it? We do it. This upon sign is 1 time, 2 times, thrice, and 4 times. There was 4 signs of upon, right? 4 signs of division. So we applied this for 1 time, 2 time, 3 time, and 4 times. When we do it 4 times, I get the answer, right? I will come across one more question. Say, let's try to solve 1 plus 1 upon 1 plus 1 upon 1 plus 1 upon 1 plus 1 upon 1 plus 1 by 3. Say, this is the question, right? So what do you do? How do we solve it, right? We solve this first. It is 4 by 3. Then 4 and 3. In the next step, 4 and 3, 7 by 4. 7 and 4, 11 by 7. 11, 7, 18 by 11. 18 and 11, 29 upon 18. Let me check it out. How many upon signs? 1, 2, 3, 4, 5. There are 5 upon signs. So we have done 1 time, twice, thrice, 4th, and 5th time. Yes, 5 times we have done. My answer will be 29 upon 18. So either you solve by this method or you solve by the traditional method. In the both the cases, you are going to get the same answer, right? So 29 upon 18. This way you save your time as well as your energy, and both are important. Time and energy both are important when we go for the actual exams, right? Fine. So I think that this concept is clear. I just want to elaborate a bit more on this concept, right? Instead of 1, if it is say 2 plus 1 upon 2 plus 1 upon 2 plus 1 upon 2 plus 1 upon 3. This question has to be solved, right? So here instead of 1, what we are getting? We are getting 2. So how do we approach? First step is same, 3 to the 6 plus 1, 7 by 3 is there. In the next step, what I do? Here it is 2. So 7 to the 14. 14 plus 3 is 17 upon this 7 goes in the denominator, 7, right? What we have done, look again, 7 by 3 we have got. Now this numerator is multiplied by this. There is 2, so 7 to the 14 plus 3, 17 upon 7. In the next step, this 17 into 2, 17 to the 34, 34 plus 7 is 41 upon 17, right? This 17 goes in the denominator, right? In the next step, again, there's 2, so 41 into 2 is 82, 82 plus 17, that is 99 upon 41. So my answer comes out to be 99 upon 41. Clear? I hope this question is easy. It becomes easy. Otherwise, if you write it and reverse it, write in reverse, add in reverse, add in reverse, then it will become very typical for you, right? Because sometimes we get confused whether I have done the right thing or wrong, right? So in this case, this approach helps you in solving the question very easy manner, right? So in case we have let's take one more example, like 1 plus 1 upon 2 plus 1 upon 3 plus 1 upon 4 plus 1 upon 5, right? If I have this question, right? Now you will solve this question. I hope that you all are carrying the pen and copy with you, right? And if you have it, you just try to go ahead and solve this question, right? What is there? 5 4s are 20 plus 1 is, it is 21 upon 5. 5 4s are 20 plus 1 is 21 upon 5. Then this is the first step. Then 21 into 3. 21 and 3 is 63 plus 5, that is 68 upon 21. In the next step, 68 into 2, that is 136 plus 21, 157 upon 68, that is the next step. And finally we have 1 only, here we have only 1, so 157 into 1 is 157 plus 68 is 225 upon 157. So this is the answer that we get. 225 upon 157, right? So this type of question we can see in the examination, and we can solve these questions in a very easy manner, very easy way, right? I hope that you have noted it down, right? You can note it down, and whenever you come across such questions, just try to solve this question by using this method, right? Very easy thing, done. Okay, so in the next part we go to the addition of some standard terms, right? In some standard digits that are asked for the addition in the fraction sum, right? Like that, you might have come across sometimes some question like you have to add 1 by 2 plus 1 by 6 plus 1 by 12 plus 1 by 20 plus 1 upon 30 plus 1 upon 42 plus 1 upon 56 plus 1 upon 72 plus 1 upon 90, and it is being asked what is the answer, right? So in this question we don't have the, we cannot find the LCM and then solve this question that way, right? Because that will be a huge number, right? We cannot do that. So we need to understand how to approach such questions, right? So one thing is very clear is when we have such lengthy questions, it's very clear that there is some tricky thing is something that is expected out of us, right? That's we need to approach the question in some specific manner so that the question will come out to be very easy one as compared to what we can see on the screen, right? So what we need to do is we need to understand what is the important these digits 2, 6, 12, 20, 30, 42, right? In the previous session I've told you one special series. This I've written 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I hope that if you can recall it right after on, and otherwise if you've forgotten, right, I'm just repeating it to you again. 1 into 2 is 2, 2 into 3 is 6, 3 4s are 12, 4 5s are 20, 5 6 are 30, 6 7s are 42, then it is 56, then it is 72, then it is 90, then it is 110, then it is 132, and so on. Right? So this series, these numbers are called special series. And what is special about these numbers? In these numbers, these are the product of two consecutive numbers. Right? All these numbers are product of two consecutive numbers. Done. So one thing we need to understand that these are the products. 2 is product of 1 and 2. 6 is product of 2 and 3. 12 is product of 3 and 4. Right? Now, another important thing I want to tell you. Right? Say if I am adding subtracting 1 by 3 and 1 by 4. There are two numbers. Out of 1 by 3 and 1 by 4, which one is more? 1 by 3 or 1 by 4? Yes. Out of this 1 by 3 and 1 by 4, which number is greater? Right? So what happens here? Here 3 is a smaller number, so it is in denominator, right? So it means this 1 by 3 will be more and 1 by 4. See, very simple. Of a one complete value, you are doing it 3 parts. Here of the complete value, you are doing it, making it only 4 parts, right? So 1 by 3 is greater than 1 by 4. And if I have to subtract 1 by 3 minus 1 by 4, I have to solve it. We take the LCM to be 3 into 4, that is 12. Now, 3 divides 12 and it comes out to 4, it's 4 minus 3 divides 12, 4 divides 12 by 3, so it is 3. Yeah, it is 4 minus 3 upon 12. You can write it this way as well, right? So what is the answer that I get? It's 1 by 12, or what I can write is 1 by 3 into 4. I just want to stress upon this important thing. 1 by 3 minus 1 by 4 is 1 3 by 4. Like 1 by 3 minus 1 by 4 is equal to 1 by 3 into 4. Right? So whenever the difference is 1, Say, I can simply write it as 1 upon product of those numbers. Say 1 upon 5 minus 1 upon 6 is given. So what I can write is 1 upon 5 into 6. 1 upon 7 minus 1 upon 8 is given. So what I write? 1 upon 7 into 8. 1 upon 11 into 12 is given, right? What I write? 1 upon 11 minus 1 upon 12. Right? I hope you understand. Yes, you can understand this thing. So whenever this difference is 1, we straightway apply this thing, right? Now, in case I take you forward, right? In case I know that I can write as 1 by 6 minus 1 by 7 is given, I can write as 1 by 6 into 7, right? This I can apply straightway, right? But on the other hand, if it is given that 1 by 8 of 8 into 9 is written, I can write it as reverse, vice versa, 1 upon 8 minus 1 upon 9. 1 upon 10 into 11 is written, I can write as 1 upon 10 minus 1 upon 11, because what we have seen in the previous slides, it's here 1 by 3 minus 1 by 4 is 1 by 3 into 4, 1 by 5 minus 1 by 6 is 1 by 5 into 6, 1 by 11 into 12 is 1 by 11 minus 1 by 12, 1 by 7 minus 1 by 8 is 1 by 7 into 1 by 8. So vice versa is also applicable, is 1 upon 7 into 8 is 1 by 7 minus 1 by 8. Right? So this is what we need to apply in this question. In this question over here, we need to apply the same thing, right? What I can write as 1 by 2 can be written as, we carry from the previous question, 1 upon 1 into 2 plus 1 upon 2 into 3 plus 1 upon 3 into 4 plus 1 upon 4 into 5 plus so on up to plus 1 upon 9 into 10. This is the question that we have. So 1 upon 1 into 2 can be written 1 upon 1 minus 1 upon 2 plus 1 upon 2 minus 1 upon 3. This is 1 upon 2 into 3, 1 upon 2 minus 1 upon 3 plus 1 upon 3 minus 1 upon 4 plus 1 upon 4 minus 1 upon 5 plus so on up to plus 1 upon 9 minus 1 upon 10. Right here. What we get? 1 by 2 cancel, 1 by 3 cancel, 1 by 4 cancel, everything will be cancelled. What will be left with? This will be cancelled. So what will be left with? The smallest number, that is 1 upon 1 minus the highest value is 1 upon 10, and we get the answer to be 9 by 10. The answer to this question will come out to be 9 upon 10. Right? I hope you understand. Right? See, I take one more example. If it is given that 1 upon 12 plus 1 upon 20 plus 1 upon 30. It has to be solved. See, it's a very simple question. Or I just add up 1 upon 42 plus 1 upon 56 plus 1 upon 72. This question is given. So what I write is 1 upon 3 into 4 plus 1 upon 4 into 5. So here I can figure out, I can generalize this. Difference between 3 and 4 is 1, and this 4 is ending here, and here from this 4 the new number is starting, this 1 upon 4 into 5 plus 1 upon 5 into 6 plus so on up to 1 upon 8 into 9. So what do we get here? It is going to be 1 upon 3 minus 1 upon 4. So here first value is positive, second value is negative, 1 upon 4. Plus, similarly, here in the next question, 1 upon 4 minus 1 upon 5. Here, the question becomes easier because these values are getting cancelled. And these will be cancelled only if there is continuity. Continuity means to say, here it is ending with 4 and here it is starting with 4. Here it is ending with 5 and here it is starting with a 5. So, it's 1 by 5 plus it will be 1 by 5 minus 1 upon 6. This will be cancelled. Next will be 1 upon 6 minus 1 upon 7. This will be cancelled. Next will be 1 upon 7 minus 1 by 8. This will be cancelled. Next will be 1 upon 8 minus 1 upon 9, and this will be cancelled. What we are left with? We are left with smallest term 1 by 3 minus highest term, that is 1 by 9. Then we take out the LCM, comes out to be 9, and this is 3 minus 1. So my answer will be 2 upon 9. My answer to this question will be 2 upon 9. So this question becomes very easy to be solved. Very simple manner we can solve this question, right? Hardly an issue. The only thing is we need to recognize what the question is asking. Done? Right? So this special series needs to be remembered. Right? I'm telling you again, this special series is important, and Do remember these values, right? Because these are going to be helpful to you once you recognize this thing, right? When you go for the questions of series as well, this special series will be helpful for you people. Done. I hope that you can solve this question now. Then apart from this, that another important thing that I would like to discuss with you is, say if it is given that 1 upon 5 minus 1 upon 7, there is a difference of 2. So in this case, what will be the value? We take out the LCM to be 35. Then here it will be 7 minus 5. So we get it to be 2 upon 35, right? So if 5 and 7, if the difference of 5 and 7 is 2, so it will be 2 upon 35, right? So if it is written as 1 upon 7 minus 1 upon 10, I can straight away write as 3 upon 70. If it is written as 1 upon 8 minus 1 upon 13, so difference between these two is 5 upon 13, it's a 104. We can write it straight away. Clear? So sometime what we get, sometime we'll come across certain questions. The question will be asked in the form like that's 1 upon 15, 1 upon 15, or say 1 upon, instead of 1 upon 15 there will be 2 upon 15. I can write it again, is 2 upon 15 plus 3 upon 40 plus 5 upon 104 plus 2 upon 195. This question is there, right? So here sometimes we feel yet how to solve this question, because this is very complex, and if we take out the LCM, the number will be very high and it will be difficult to solve this question, right? So here we need to understand the how, what are these two values. This is basically 3 into 5, right? Next we check it out whether this number 5, because it has to be in continuity, whether this 5 is dividing this is 5 into 8. Then if this 8 is dividing this is 8 into 13. Then is this 13 is dividing next number, this is 13 into 15, right? And next thing we check it out, what is the difference between these two? Difference is 2 is there. Difference is 3 is there. Difference is 5 is there. Difference 2 is there, right? So basically this question is 2 upon 3 into 5 plus 3 upon 5 into 8 plus 5 upon 8 into 13 plus 2 upon 13 into 15. So in this case, what I can write is 1 by 3 minus 1 upon 5 plus 1 upon 5 minus 1 upon 8 plus 1 upon 8 minus 1 upon 13 plus 1 upon 13 minus 1 upon 15. So this gets cancelled, this gets cancelled, this gets cancelled. So what I'm left is 1 upon 3 minus 1 upon 15. And the LCM is 15, so it is 5 minus 1, that comes out to be 4 upon 15. So my answer to this question comes out to be 4 upon 15, right? Very easy question, very easily we can find it out, but we need to recognize it. We need to identify this series. Once we have identified these digits, then the question is, after this the question will become very easy for you, right? Done. I take out one more example, right? So let's go to the one question, right? Sometime you'll get this question like say 1 by 3 plus 1 by 15 plus 1 by 35 plus 1 by 63 plus 1 by 99, right? So what is the answer for this question? Here the difference might be different, but here nothing is mentioned over there, right? So there, in the numerator there is always there is going to 1, right, in all the 5 cases. So how do we approach this? This is 1 upon 1 into 3 plus 1 upon 3 into 5 plus 1 upon 5 into 7 plus 1 upon 7 into 9 plus 1 upon 9 into 11 in this case, right? So if we move ahead, if we go ahead, what do we get? Is 1 upon 1 into 3 into 5, right? So in this case, I know this. If I solve, say 1 upon 1 minus 1 upon 3, this will come into 2 upon 3 2 upon 1 into 3. Similarly, this will be, if I solve 1 by 3 minus 1 by 5, right? So what I will get? I will get here 2 upon 3 into 5. So here I have 1 upon 3 into 5, 2 is not there. So what I can write is, I can write this value equal to 1 by 2. Sorry, if I have the value I have 1 upon 3 into 5, what I can write is 1 by 2. Instead of 2, keeping 2 here, if I have this value only, so I can divide this by 2 and I can write 1 upon 3 minus 1 upon 5. Right? This way I can follow this question. Right? Or you can say that you can divide this whole equation by 2. What I get? 1 into 3 plus 2 into 3 upon 5 plus 2 upon 5 into 7 plus 2 upon 7 into 9 plus 2 upon 9 into 11, right? So what I get, what do we get? This sum is going to be 1 by 2 is taken out, 1 by 2 is here, then into, it is 2 upon 1 by 1 into 3 is 1 by 1 minus 1 by 3, plus next will be 1 by 3 minus 1 upon 5, plus on. Last term will be 1 upon 9 minus 1 upon 11. So what do you get? This gets cancelled, this gets cancelled, everything gets cancelled. What we are left with? 1 by 2 into 1 by 1 minus 1 by 11. So we can generalize that 1 by 2 into 10 by 11, the answer will be 5 by 11. My answer to this question is 5 upon 11. Done? Right? So we can solve this question, this sort of question are being asked, but this is a lengthy method, right? This is consuming a lot of time. We need to understand that how this answer is framing up directly, right? In this case, what if we have identified this thing? If I have identified this question, right? This is the question, right? After this stage, I know this continuity, this 3, 3, 5, 5, 7, 7, 9, 9, and I know the gap is 2, 2, 2, 2. Gap is same. So what I write here, the answer will be 1 upon gap, 1 upon gap or 1 upon difference upon into 1 upon smallest number minus 1 upon highest number, right? Like in this case, what I can do is 1 upon gap is 2 into 1 upon smallest number is 1, my highest number is 11, and my answer is 1 by 2 into 10 by 11, and answer will be 5 by 11. I get the answer to be 5 by 11. Done? Question is easy. From this step, straightway we can just write down the answer. Like I take one more example. Like for example, if I have a number, say I'm multiplying this numbers 1 by 4 plus 1 by 28 plus 1 by 70 plus 1 by 130 plus 1 by say 208, right? So what it is? It is basically 1 upon 1 into 4 plus 1 upon 4 into 7 plus 1 upon 7 into 10 plus 1 upon 10 into 13 plus 1 upon 13 into 16, right? So there is continuously this gap of 3 each, and there is continuity 4, 7, 10, 13. So what I do? 1 upon difference, that is 3, gap is 3, upon 1 of smallest number is 1, my highest number is 16. So 1 by 3 into 15 upon 16, and my answer comes out to be 5 upon 16. My answer to this question will become 5 upon 16. I hope this concept is clear, right? And you can note it down. You can practice few more examples. You can just I have already discussed somewhere 4 to 5 questions on the same pattern, right? And you can go back, you can solve these questions, and things will become easy for you. Fine, right? I don't think I don't find it will be much difficult for you people, right? I can just help you with one more example. Say it is given the 1 upon 2 plus 1 upon 8 plus 2 upon 1 by 4, that is 1 by 4 is given, 1 by 4 is going to plus, say it is 8, if it is 4, 6, 7, then it is 3 upon 28, then it is 4 upon 77, then it is 5 upon 1, 176, right? If this question is there, we have to solve it, right? So what I can do, 1 upon 1 into 2, we have to just bring this question to that category, right? We need to understand how the question is being framed out, right? 1 upon 1 into 2, right? Plus 1 upon 1 into 4 is there, right? So 1 upon 1 into 4 I can write plus, but here continuity is ending. So what I need to, here it is 2, then again we need to have 2 over here. So here we need to have 2. So what I write, it's 2, 2 upon 4 plus this 3, 4 into 7 plus, because this 4 will help us to form which this number will start, 4 into 7. Then next is 4 upon 7 into 11. Next is 5 upon 11 into 16. So my question is very easy. It's a 1 by 1 minus, so, or you can simply straight away write the result, because I know this 2, 3, 4, 5 are going to be cancelled. So my answer is 1 upon 1 minus 1 upon 16, and my answer will come to 15 upon 16. Straight away I write this answer, right? You can just spend some time with this concept, right? Just spend some time with this concept, and then the question will become very easy for you, right? And if you like this concept, if you like this session, right, you can just press the you can just like the video, you can share the video, so that we can reach out to the more candidates, we can help more and more students, right, who are looking for the quality education, right? Next, after this, we go to the last concept of the fractions, that is comparison of fractions. That is comparison of fractions. Comparison of fractions. That how do we compare the fractions, right? So when we go for the comparison of fractions, so in exam we get the question like that, the fractions are written like 3 upon 7. Then it is 8 upon 11, then 5 upon 8, then 2 by 5, and then it is say 9 upon 13, right? So we need to find out of these 5 fractions, which fraction is the smallest one, which fraction is the highest one, which is the second highest, which is the second lowest, which is the middle term, right? So normally, in order to solve this question, what we are expected to do, we are expected to find the LCM and make the denominator same for all the fractions, and then we have to solve this question. But here, when the question is asked in the exam, we hardly have say 15 to 20 or 30 seconds to solve this question. So in order to solve this question, what we do, we use a very simple concept. We simply add up zeros, because we add up 0 with every number, right? We simply add a 0 with each and every number, right? And then divide it by denominator. 7 into 4 is 28, 11 into 7 is 88, 77, 8 into 6 is 48, 5 into 4, and 13 into 6, right? Okay, so from this values, these are the values, right? From these values, I can very clearly say, so the highest number is this one, right? And if we talk about the lowest number, this is lowest number will be out of this and this, that is 3 by 7 or 2 by 5. But here I know 20 upon 5 is completely 4, is 4, nothing after that. But here, if I add one more 0, what I will get? I will get only 40 here. Add 7 4s are 28, then 2 20, 7 2s are 40. So I get 42 over here. So this number is higher as compared to this one. So lowest number will be 2 upon 5. If I have to compare further between 5 by 8 and 9 by 13, so what I can do, I can add one more 0 over there and one more 0 over there. So 8 6 are 48, 2 balance, 2 is 20, 8 2s are 16, 13, 6 are 78, 13 to 6, that is 78, 12 is balance and 0, 120, the 39 is the 117. So the highest number is this one, second highest is 1, this one, third highest is this, fourth position this, and at fifth position is this 2.5. So we can easily categorize all these fractions in one step. What we are doing, we are simply adding up the 0 with each of the fraction and divide it by the denominator. And if we can categorize based upon that, this much calculation, then it's okay. Otherwise, we can add up more zeros, right? Like I take one more example. Look here, it is the fraction is 5.7. 5.7 is one fraction. Then 9 by 11 is another fraction. Then 4 by 7 is another one. 3 by 5 is one fraction. 10 by 70 is another one, right? So we need to figure out this, where do these fractions lie. So what we do, we add up 0, 0, 0 with each of the fractions. Now 7 into 7, 49. 7 into 7, 49. 11 into 8, 88. 7 into 5, 35. 5 into 6, that is 30. And 17 into 5, 85. Right? So we know the first position is this, second is this one, third is this one. Highest is 9 by 11, second is this, third is this. Now out of these two fractions, we need to figure out which one is the higher one, right? So what we can do, we can add up one more 0 with each. 7 5s are 35, 5 is 50, 7 7s are 49. 17, 75 is 85, 15 is left. So it is 0, 150, so 17 8s are 136, right? 17 8s are 136. So fourth position is this, and smallest number as this one, 4 by 7. Here, in order to categorize this, we could also have done, what we can do is 4 by 7 and 10 by 17. These are the two numbers. This is 4 by 7 and 10 by 17, right? If I have to compare these two fractions only, then we can apply a very simple approach that we have done in the lower class. In the 8th, 9th class, we used to solve these questions. 17 into 4. 17 4s is 68, and 7 into 10 is 70. So 68 is a smaller number, 70 is a higher number. So 10 by 17 will be a higher value, right? Where we get a higher value, that number is high, right? 70 is a bigger value, so I get 10 by 17. 68 is smaller values, I get the 4 by 7, right? So this is how we get the answer. This is how we solve the questions. Clear? So it's very easy to compare the fractions, very easy to simplify these things, and simply only thing that I have told you, that what you need to do is you need to just add up zeros into this, right? So next I would say that in today's class, that I hope that you learned the concepts of fractions, right? What you need to do, you note down these important concepts, solve the questions related to these concepts, right? And make as much use of these fractions as possible, because once you practice these fractions, only then you will be able to understand the concepts clearly and actually apply the things in the exam, right? And before that, I have also told you in the previous lectures that you come prepared with the tables and squares and cubes, because once you have good command of the tables, that's going to help you very much in the exams, right? So that's it for the today's sessions. I hope you enjoyed the session. Wish you all the best. Thank you.